Hello, today we're going to be looking at atoms, nuclei and specific charge. This is the first topic from the particle physics module. We'll be covering the charge and mass of the proton, electron and neutron. We'll discuss the use of nuclear notation and what is meant by an isotope. And finally, we'll be calculating the specific charge of a particle, primarily nuclei or ions. When following these lessons, I advise you sit with a pen and paper. You will also very likely need a scientific calculator and a data sheet. At various points throughout the video, I'll ask you to stop and answer a question. You may have learned previously that the mass of a proton and a neutron is equal to 1, and the mass of an electron is 1 part in 1800 the mass of a proton. You also probably learned that the proton has a positive charge, the neutron has a neutral charge, and the electron has a negative charge. In many situations, however, it's much more useful to give the mass and charge in some unit. At the moment, we'll be sticking to SI units, that is, kilograms and coulombs. The mass of the electron is 9.11 times 10 to the minus 31 kilograms. The proton and the neutron have almost the same mass, 1.67 times 10 to the minus 27 kilograms. The proton has a positive charge, 1.6 times 10 to the minus 19 coulomb, and the electron has a negative charge, minus 1.6 times 10 to the minus 19 coulomb. Although you don't need to remember these, it may be worth you pausing the video at this point to fill in the remainder of the table, just to familiarize yourself with these quantities. And here are the completed values. It's also very important that we recall nuclear notation. Shown on the left-hand side is the nuclear notation for an atom of calcium. The bottom number is known as the proton number. In your chemistry class, it may have been referred to as the atomic number. The proton number is quite simply the number of protons inside a nucleus. The top number is known as the nucleon number. It's referred to sometimes as the mass number. It represents the number of protons plus the number of neutrons inside a nucleus. A nucleon is the collective name for either a proton or a neutron. Nuclear notation gives us a clear way to represent the isotopes of atoms. An isotope is simply an element that contains a different number of neutrons. For example, carbon always has 6 protons. However, some atoms of carbon may have 12 nucleons, whereas some atoms may have 13 nucleons. The difference is that they have a different number of neutrons. Lastly today, we're going to calculate the specific charge of various particles. Primarily, we must be able to calculate the specific charge of a nucleus or an ion, and we'll go over each of these terms in turn. Firstly, specific charge is simply the ratio of the charge of a particle to its mass. Its units are coulombs per kilogram. This may be best understood through an example. Let's say we want to calculate the specific charge of a nucleus of carbon-12. The charge of the nucleus is simply 6 multiplied by the charge of a single proton, since carbon contains 6 protons. So it's 6 multiplied by 1.6 times 10 to the minus 19 coulombs. To work out the mass, we need to do 12 times 1.67 times 10 to the minus 27 kilograms. That's because carbon-12 contains 12 nucleons. If you put this into your calculator, you'll see that the final answer comes out as 4.8 times 10 to the 7 coulombs per kilogram. Here's a question for you to have a go at yourself. Which of these nuclei has the smallest specific charge? Is it hydrogen, carbon-12, carbon-14, or uranium-235? Pause the video and have a go yourself. The answer is D. The keen amongst you may have also realized it's sufficient to take the ratio of the proton number to the nucleon number to answer this question. Finally, let's calculate the specific charge of an ion. An ion is an atom which has a non-zero charge. This can either be through losing or gaining an electron. For example, let's calculate the specific charge of an ion of carbon-12, where the ion has a relative charge of +2, having lost 2 electrons. The charge of an ion is 2 times 1.6 times 10 to the minus 19 coulomb. However, the mass is still 12 times 1.67 times 10 to the minus 27 to account for the 12 nucleons inside the nucleus. The final answer would be 1.6 times 10 to the 7 coulombs per kilogram. Finally, here's a quick exam question for you to try. Pause the video and try and answer these 3 questions on your own. And finally, here are the answers to that last exam question.